Hey guys, welcome back to chapter 4. We have wrapped up our discussion on ionic compounds. We are going to talk about naming covalent compounds. So the second half of this chapter is all things covalent. So we'll dive much deeper into some of the other stuff. But right now we're just going to focus on how do we name these guys and how is that different than ionic. So just as a reminder, covalent is going to be a nonmetal bound to another nonmetal. So the first step is going to be identifying it as covalent. Remember the nonmetals are that teeny tiny little section in the top right corner of the periodic table. Things like nitrogen, oxygen, fluorine, that sort of thing. With covalent compounds, the other difference is the electrons are shared. Because electrons are shared, we don't have charges that kind of dictate or define how many of each element can get into the bond. So for example, sodium chloride, the only option is one sodium and one chlorine. We can't have two sodiums and one chlorine. We can't have 5 chlorines and one sodium. It's dictated by the charge, 1 and 1. That's it. For covalent, we can have any number of combinations. So here's just an example of some of the combinations that we'll see. So for example, down here at the bottom left, water is H2O. So we've got 2 hydrogens, that's the white dots here, and 1 oxygen. So in that, we've got 2 hydrogens, 1 oxygen. Another molecule that exists is hydrogen peroxide. So it's 2 hydrogens, but this time we've got 2 oxygens. So 2 hydrogens, 2 oxygens. So that's just kind of a little preview as like we can have any combination of atoms. We can have 2 hydrogens, 1 oxygen, 2 hydrogens, 2 oxygens, 2 oxygens, 3 hydrogens, 1 oxygen, 3 hydrogens. And this can get carried away, honestly. We could have a very large array of ratios. So when we go to name covalent compounds, we have to tell the viewer how many of each atom is there. So because this can vary from molecule to molecule, it's important that we tell them how many we see. So what you'll see with this is each of these names will need a prefix. So the prefix is going to tell us how many of that particular atom we have. So for example, if we've got 1 of something, the prefix would be mono. If we've got 5 hydrogens, for example, the prefix would be pentahydrogen. If we've got 8 of something, the prefix will be octa. Okay? So this prefix will tell the viewer how many of each atom we have. So to name the compounds, it's actually going to look very similar to ionic, where we have the name of the first element. It doesn't change, we just write it down. We have the base name of the second element plus IDE. The new piece here is this yellow box, and that's going to be the prefixes. We have to tell the viewer how many. All right, so let's look at this first example together, the N2O. So I'm just going to get the part down that I already know how to do. So I'm going to write the name of the first element. So I'm going to write nitrogen. I'm going to write the base name of the second element plus IDE. So base name for oxygen is just the ox. And I'm going to add IDE. So nitrogen oxide. Now I have to go back and I have to tell the viewer how many of each of these we have. So this subscript nitrogen here is a 2. When I have 2 of something, that prefix is di. So I'm going to write di nitrogen. And then for oxygen, remember 1s are implied. So there's 1 oxygen. I'm going to write mono. So just a little kind of exception here, but it's pretty easy to remember. We don't typically say monoxide. That's a lot of vowels. So if the element starts with a vowel, often we would drop this extra O. So the way that I would read this would just be monoxide. oxide. So the name of this first element or first compound is dinitrogen monoxide. So go ahead and pause the video and see if you can write the name of this guy over here. All right, so again, I'm going to write the name of the element. So I'm going to write nitrogen. Base name of the second, ox, add IDE, oxide. Now I have to go back and tell the viewer how many of each we have. So I'm going to write dinitrogen. And this time we have 5 oxygens, so that would be penta. But again, we start with a vowel, so I'm going to drop this extra A, and we would say pent oxide. So dinitrogen pentoxide. Okay. There's one more exception to the rule that I want to talk about. So the first exception was that like extra vowel pentaoxide versus pentoxide. The second exception to the rule is something that you're actually already familiar with. Okay, so let me get a blank slide here. We'll just do it on, we'll do it on this slide right here. So I want you guys to think about the name of this compound. If I were to systematically name it based on the rules we just learned, we'd write the name of the first, so that would be carbon. Base name of the second plus IDE, oxide. Go back and tell the viewer how many we have. So we've got 1 oxygen. Drop that extra O, so that would be monoxide. And according to our systematic naming, we've also got 1 carbon, so we would put mono here as well. But do we say monocarbon monoxide? No, we don't. What do we call this? Simply carbon monoxide. So that's the second exception to the rule. We do not start a name with mono. So we don't say monocarbon monoxide. We don't say monocarbon dioxide, right? We would say carbon monoxide, carbon dioxide. Okay. If the number was anything other than a 1 here, so let me just make something up. Let's say this was a 6. Ooh. Let's say this was a 6. Then we absolutely would put the prefix hexa in front, and we would say hexacarbon monoxide. But we just don't start a word or a name with mono. Okay. So 2 exceptions to the rule, pretty easy because we use them somewhat standardly. So hopefully you guys can remember those. That's it for covalent naming. First, identify it as a covalent compound, and then just make sure we write the prefixes to tell them how many. Hope you guys found this helpful.